Welcome back to my channel. We have this figure formed by four lines with indicated angles A, B, C, and D. The task is to find the sum A plus B plus C plus D. Alright, what I'm going to do first is introduce the main tool that we are going to use to solve the problem. This tool is actually a property of non-convex quadrilateral involving its angles. So let us consider this non-convex quadrilateral with angles P, Q, R, and S. I'm going to show first that P is equal to Q plus R plus S, and then we will apply this one to the problem that we have. Okay, to show this, I'll construct a line passing through the vertices of angles P and R, dividing the non-convex quadrilateral into two triangles. Suppose that this line divides P into P1 and P2 such that P is equal to P1 plus P2. Similarly, suppose that this line also divides R into R1 and R2 such that R is equal to R1 plus R2. Now, I'm going to apply the so-called exterior angle theorem, which states that in a triangle, any exterior angle is equal to the sum of its two remote interior angles. So we have that P1 is equal to Q plus R1 and P2 is equal to S plus R2. Now if we add these two equations, we get P1 plus P2 equals Q plus S plus R1 plus R2. But take note that P1 plus P2 is equal to P and R1 plus R2 is equal to R. So this equation becomes P equals Q plus S plus R. So now we have shown that P is equal to Q plus R plus S. Now let's apply this one to the problem. However, we need these three angles. How can we get these? We can just subtract each of A, C, and D from 180 degrees. So the three angles are 180 degrees minus C, 180 degrees minus A, and 180 degrees minus D. So using the property we've found, or we have shown before, we have that B is equal to the sum of 180 degrees minus C, 180 degrees minus A, and 180 degrees minus D. Then we have B is equal to 540 degrees minus A minus C minus D. Now, moving negative A, negative C, negative D over the other side, we must have A plus B plus C plus D equals 540 degrees. So the sum of the four angles is 540 degrees, and this is our final answer.